In this session, what we are going to learn is about entity relation models to relational data model mapping. So last week we learned that we can model the real world scenarios using the entity relation model. And today we will discuss how we can come up with the database schema using those entity relationship models and entity relationship diagrams that we created. And for that, we are going to use a 7-step process. So before getting into that 7-step process, let's take a look at a sample ER diagram for a certain company or an organization. So here we have 4 entities. We have an employee entity that has SSN or social security number as the primary key, and also certain attributes describing the name, birthday, address, gender, salary, and phone numbers. And as you can see, an employee may work for a particular department which has an ID as the primary key, name, location as its attribute. And you can see that it's a many-to-one relationship. So that means one department may have many employees. And also there's another relationship between the employee and the department, that is managers. So a department have a single manager or an employee that manages this department starting from a particular date. And a department also have or controls certain projects or many projects, and for a particular project there has to be a one department. And also there's another relationship between employee and employee itself, that is supervise. So that indicates an employee can have another employee as the supervisor. So that's a one-to-many relationship. So a certain employee may supervise many other employees. And we have another relationship here that has a double diamond. So that indicates it's a weak entity, and this employee entity set is going to be the identifying entity set using this identifying relationship. So we have the weak entity set as the dependent. So that is basically any dependent of a particular employee belongs to this entity set. So since without an employee, we are not really concerned about a dependent, we consider it as a weak entity set here. So a dependent can only exist in this case with an employee. And we also have another relationship right here, works for. So a particular employee may work for many projects, and a certain project may have many number of employees working on it. So that's the whole idea about this particular ER diagram. So now we are going to use this particular ER diagram or the ER model throughout this lesson, and we are going to use our 7-step process to convert this ER diagram into a relational model schema or the database schema for this particular organization. Let's first look at the step 1 of our 7-step process, that is identifying strong entity sets. So as the first step, what we are going to do is for each strong entity set in our ER diagram or ER model, we have to create a corresponding relation. So remember, a relation means a table. So we have to identify all the strong entity sets and create corresponding relations for them. And we have to include all the simple attributes of that entity set in the particular relation. And for any composite attributes, so again, if I remember what composite attributes are, the attributes that are made of subparts are known as composite attributes. For example, if we have a name for a person and if the name is composed of certain subparts like first name, last names, initials, so on, we can consider it as a composite attribute. And for that kind of attributes, we have to include the simple components of that attribute into the created relation. So we are not going to include the composite attribute, but rather we will have the subparts of that as separate attributes. And then we have to choose one of the key attributes or set of attributes as the primary key. So from the identified key attributes in the ER model, we can choose one or set of attributes as the primary key for the relation. And if there are other remaining key attributes, we can keep them as secondary unique keys, which we will later learn as indexing. So for now, just remind that we can also keep these other attributes which have unique values, but which are not going to be used as a primary key. We can later use them for a different purpose known as indexing. So let's take a look at our ER diagram and try to identify the strong entities or strong entity sets in this diagram. So here we have an employee that is a strong entity set, and we have a department, another strong entity set, and project. So we already identified the dependent as a weak entity set. So except that all other entities are strong entity sets. So now what we have to do is create a relation for each of these three entity sets. So we will have a relation for employee, department, and project. And all of them have simple attributes except this phone numbers, which is a multivalued attribute. And if you consider the name as a composite attribute made up of first name and last name, except those two, others are simple attributes. So that means when we create the relation for those three strong entity sets, we will have an employee relation, primary key SSN, first name, last name. Those are the simple subparts of the composite attribute name. So we have included them separately. And these are the other simple attributes that came from the entity set: birthday, gender, and salary. So you can see the multivalued attribute phone numbers is not included here. So it was not specified in the step 1. And the department relation, so it has the primary key ID, name, location, project, again ID, name, and the budget. So these are simple attributes that came from the ER diagram. So this is what we should have after the step 1. Now let's move on to the second step, identifying weak entity sets. So the steps 2 says for each weak entity set, create a corresponding relation that includes all the simple attributes. So similar to a strong entity set, we have to do the same thing for a weak entity set. identify the entity sets, create a relation for each of them. And not only that, we have to have all the primary key attributes of the identifying entity set as foreign keys in the weak entity sets relation. And the primary key for the weak entity sets relation will be the combination of all the primary key attributes from the identifying entity set, which we included as foreign keys, plus the partial key or the discriminator of the weak entity set. So let's check our ER diagram. So we know this dependent entity set is a weak entity set identified by the relationship of dependent using the strong entity set of employee. So this is the identifying entity set for the dependent. So now what we have to do according to step 2 is create a relation dependent, include all the simple attributes, and also take whatever the primary key from this employee relation and include that as a foreign key in the dependent relation. So let's see. So we already had this after step 1, and now in the step 2 we have added this highlighted part. We have created the new relation dependent. Simple attributes are included, name and birthday. And also the primary key of the identifying relation employee SSN included here as a foreign key employee SSN. And the primary key for the dependent relation is now the foreign key plus the partial key of dependent entity set name. So these two together is taken as the primary key. Now the step 3. So after step 1 and 2, we have created relations for all the entity sets. Now what we are going to do is we are trying to convert or map the relationships in the ER diagram into the relational model schema. So step 3, we are going to include binary one-to-one relationships. So when we say binary, that means only two entity sets participate in the relationship. So for each binary one-to-one relationship R in the ER model, we have to identify the relations S and T that participate in that relationship R. So let's say this is one entity, this is another entity participate in the relationship R, and it has a attribute X. So what this says is for each relationship R, we have to identify the relations S and T that corresponds to the entity types participating in R. So we have to identify what is the relation that or the table that we created for this particular entity. So let's say S, and what is the table or the relation correspond to this entity set. Let's say T. And now we have to choose one of the relations, let's say S, and include the primary key of T as a foreign key in S. So we have to include T's ID or whatever the primary key here in S as a foreign key. And if there are simple attributes belongs into the relationship, we can include them also under the relation S. So you can see this attribute X now goes under the relationship S. And when we choose this S and T, better to choose an entity type with total participation in R as S. So as we said, we can either include T's primary key in S, or we can include S primary key in T as foreign key. So since it's a one-to-one relationship, whatever the we choose, it will give us the same result. But as a good practice, we should try to choose if there's an entity set with total participation, that side as S. Why we want to do that is it will reduce the null values. Now since S has total participation, each and every record under S will have a related value or a related record in T. So every record in relation S will have a foreign key value corresponding to T. If we do it other way, if we choose S as the side where we don't have a total participation, then for those record that does not have a relationship, there will be null values for the foreign key. So in databases, we don't really like to have null values unless we can't avoid it. So as a good practice, it's better to choose the side with total participation as S. And alternatively, we can do another thing, that is merge the two entity types and the relationship into a single relation. And that is only possible when both participation or the both participant entity sets have a total participation. So that means one-to-one total participation from both sides. That means each and every record in S have a single record correspond to that in T. So that means we can have all the values of T as part of S by merging them together. So we don't need to have another table T. So again, remember that is only possible when both entity sets have total participation. So let's again take a look at our ER diagram, and let's see if we have any one-to-one binary relationships. So here we have one employee have manages one department managed by one employee, one-to-one binary relationship. And as you can see, this side has a total participation. So that means we can choose department as S, employee as T, and include employee's primary key as part of department relation. And we also have some attributes under manager's relationship. So this attribute will also go under the department relation. So we already had this from step 2 and step 1. So now we have included manager SSN, that is the primary key of employee, and manager SDate, which came from the start date of the manager's relationship. And now we have come to the step 4, binary one-to-many relationships or binary one-to-n relationships. So for each binary one-to-n relationship R in the ER diagram, we had to identify the relation S that represents the entity set at the many side or n side. So let's take a look at this diagram. So we have one entity set and another entity set. We have many to one relationship here. So when we say one to many relationship, that includes one to many and many to one, both types. Since many to one can be read as one to many, when you change the perspective, both of them, those relationships are the same. So what this says is we have to identify the relation S that correspond to the entity set on the many side. So this is the many side. As you can see, this side has arrowhead, so that is 1. This is many. So this side would be n, and this is the relation correspond to the this entity set. And now what we have to do is include the primary key of the relation T, that is the other entity sets relation, as a foreign key in S. So again, this ID will go here as a foreign key. So that would be T ID. And if there are any simple attributes in the relationship R, they also go here with relation S. So this attribute X will be included here. So let's again take a look at our ER diagram, and let's see if we have any one-to-many relationships. So here we have one department has many or controls many projects, and here we have another one, supervise. So one employee may supervise many other employees. So 1 to n again. So for this relationship, we have to take project as S since it's the many side, and include department's ID as a foreign key for the project. And same goes here, since it's only one entity set is included here anyway, we will have this primary key again inserted in the same employee relation as a foreign key. There's another one-to-many relationship here. Employee works for one department, and one department have many employees. So again, this should be the many side S. So the department's ID should be included here as a foreign key. So this is what we get after step 4. Dept ID coming from the primary key of department table. And this is supervisor SSN, the primary key of the supervisor for this particular employee, the primary key of here. And dip ID for project table, that is the primary key of department table. And the step 5 says binary M to N relationships. For each binary M to N relationship, that is many to many relationship R, create a new relation S to represent R. So you can notice that since these are many to many relationships, now we can't include primary key of either of the tables in the other table as a foreign key, since it's a many to many relation. So that means we have to create a new relation or table, let's say S, to represent this relationship, and include the primary keys of the relations that represent the participating entity sets as foreign key in S. So we create a new relation S and include the primary keys of both entity sets as part of the new relation S. Also include any simple attributes of the relationship R as attribute in S, and the combination of the foreign keys form the primary key for S. So let's see if we have any many to many relationships. So here we have employee works on many projects, and the project may have many employees. So this is a many to many relationship. So as you can see, we can't have the project ID and the employee, since a single employee have many projects, and we can't have the employee ID and the project, since a single project may have many number of employees. So we can't have both. So what we do is we create a new table works on representing this relationship, and include the employee's primary key and project's primary key as foreign keys, and they together form the primary key for this table. And the sixth step is about multivalued attributes. In our first step, we didn't talk about multivalued attributes. We only included simple attributes and composite attributes, and we skipped multivalued attributes. So now in step 6, what we do is, for each multivalued attribute A of relation R, create a new relation S. So if we have an attribute A, which is a multivalued attribute, we have to create a new relation S and add that corresponding attribute to S. And also add the primary key of the relation that A belongs to, let's say R, to the relation S as a foreign key. The primary key of the new table S is the combination of the attribute and the foreign key that came from R. So in our ER diagram, we earlier skipped this multivalued attribute phone numbers. So now what we have to do is create a new relation phone numbers, include the number as attribute, and get the primary key from employee table and put it here as employee SSN. So that's the foreign key. This is where we are going to hold values for the numbers. For this particular employee, this is a number, and for the same employee, this is another number. So we will have both of them together as the primary key. And our seventh step and the final step is mapping N-ary relationships. That is any relationship of higher order than binary relationships. So last week we discussed that we can have more than binary relationships where multiple, maybe 3 or 4 different entity sets participating in the same relationship. For that kind of relationship R, we have to create a new relation S to represent R and include the primary keys of all the relations that participate in this relationship as foreign keys under S. Also include any simple attributes that belong to the relationship as attributes in S. And the primary key of this new relation S is usually the combination of all the foreign keys. So if we have a three-way relationship, we need to have the primary keys of all three tables as foreign keys, and they will be usually the primary key as well. However, if the cardinality constraint on any of the participating sets E is 1, then their foreign key is not needed to be included in the primary key of S. Why? Let's clarify with this simple example. So let's say we have this three-way relationship where a supplier supplies certain items for a project. So all the three parties have many as the cardinality. So in this case, we will have the mapping relationship created as supplies. We have the project ID, item ID, and the supplier's ID, all three primary keys as foreign keys. So since all of them have many cardinality, we need to have all three in the primary key of supplies table. So the combination of all three. And here we have a different example. Again, a three-way relationship where a particular course is conducted by or offered by a particular lecturer in a particular semester. But in this case, the semester side has the cardinality of 1. That means for a particular course conducted by a lecturer that is offered in a single semester. For one combination of lecturer and a course that is only available in a one semester. So again, if we created the relation or table of first, course ID, lecture ID, semester ID, all three foreign keys. But since semester has a one cardinality, we don't have to include it in the primary key. We can have course ID and lecture ID together as the primary key, and that should be sufficient to uniquely identify each row. Since any combination of course and a lecturer should only be available in a single semester, there won't be duplicate values for this attribute. So we don't need to have this. If you want, you can include it as a part of primary key as well. And now let's see about schema diagrams. So far in this lesson, we created a relational model schema by writing it using the notation that we learned in a previous lesson. By just writing the table name followed by the set of attributes within brackets, and the primary keys were underlined. So that is a simple enough notation to represent a database schema. But they can be also depicted using schema diagrams as well. But for this, unlike ER diagrams, we don't have a specific format. And most of the time, the format depends on the diagramming tool we use. But usually, this schema diagram will have a somewhat similar format to the ER diagrams, and each table or relation appear as a box with the relation name at the top and the attribute list inside the second half of the box. And again, primary keys attributes are usually underlined. And to represent foreign keys, we usually draw lines or arrows from the foreign key to whatever the related other table. And sometimes we might also show the domain types of each attribute. So here we have a example schema diagram for the company database that we discussed in this lesson. So this diagram is for the final schema that we came up with after applying the 7 steps. So as you can see, we have each relation depicted as a box. The name is on the top and followed by the set of attributes as a list. And to represent foreign keys, as you can see here, this employee SSN goes as an arrow to the related employee table, and it indicates that this actually came from this primary key. And even here, this department ID, you can see, goes like an arrow and shows that it came from this primary key of department's ID. So this is one way how you can draw this schema diagram. So I'll show you a different way, mostly similar, but as you can see, we have included the domain type for each of these attributes. So you can see department table, we have ID, which is an integer, name Vacha, location Vacha, and manager SSN and manager start date, int and a date. So again, we have lines connecting the foreign keys to primary keys. So these two diagrams were drawn using two different diagramming tools. So depending on the tool we use or the way we want to draw it, the format can be slightly different. But the universally kind of agreed approach is to have boxes for diagrams, boxes representing tables, and lines or arrows connecting foreign keys.